Hey, hope you're doing well. We are looking at the solution to problem 6. This one's nice and straightforward. We do end up over on the PM side of the chronometer, and we subtract 8 hours because we have a far west longitude, which brings us to the morning when we took the bearing local time, but we stay in the same day. GMT is the same day as we took the bearing. This is a good problem, nice and straightforward. Take your time and enjoy. Let's get started.
All right, let's solve practice problem 6. We're going to solve for deviation using the amplitude of the sun when it's on the celestial horizon. So this is problem 6. Let's jot that down. Okay, problem 6. And in all these problems, they give us information. Come the givens. So the first thing they'll give us is the date. The date is equal to January 11th. And all of them take place 1981, all these training problems. It gives us our vessel's zone time. This is actually extra information in this problem. We don't need that. I just know that from experience. The DR position is the next thing. Dead reckoning position is 2430, so latitude 24 degrees 30 minutes north, 24 degrees 30 minutes north, and it gives us our longitude. Part of the position is 122 degrees, 122 degrees and 2 minutes west. And when an amplitude of the sun is observed, the sun centers on the celestial horizon and bears 101 degrees. So it gives us the sun's bearing, which is 101 degrees PSC. Variation in the area is 11.6. Variation equals 11.6 degrees east. And the chronometer reads 2:52:48. So the chron time. Chron time is equal to 2:52:48. 2:52:48. And these are hours, minutes, and seconds. And then it's going to give us the chron error, which is equal to 2:12, slow. 2 minutes, 12 seconds, and that is slow. And when it's slow, we add it to catch up. And what's the deviation of the standard compass? So the question here is, what is the deviation? That is what we're wondering. First step, we need to find the GMT. Excuse me, the Greenwich Mean Time. So Greenwich Mean Time, to find that, we take the chron time, which is 2:52:48, 2:52:48, and we correct it with 2:12, 2 minutes, 12 seconds. It's slow, so we add it. We're going to add this. So we're going to get 48 plus 12, so that's 60, right? 8 and 2 is 0, 1, that's 5, 6, 60 seconds, 54 minutes, 2 hours, 54 minutes. And so this 60, 60 seconds equals a minute. So this is going to end up, whoa, sharp pencil there, 2 hours, 55 minutes, 0 seconds. Now, chronometers, they're only 12 hours, so there's ambiguity in this thing. So if we need to figure out if we're AM or PM, right? So we add 12 hours, which this leads us to 14 hours, 55 minutes, 0 seconds. Now, which one of these, AM or PM, are we in? So what we need to do now is get our local mean time when we took this thing, when we took this bearing of the sun. So we can take our longitude, which is equal to 122 west, 122 degrees west divided by 15. That'll give us how many hours away from Greenwich we are. 122 divided by 15 equals 8.13. For this, we always use whole numbers when we round up and down. So this is just 8 hours. Now, are we going to add or subtract that 8 hours? If these are time zones, to the east, we add. And if we're west, we subtract. You can think if you're in New York and you talk about California, their time is earlier. They subtract. So this is going to be west. We're going to subtract this 8 hours to get our approximate local mean time. So if we subtract 8 hours from these, what happens? So to subtract 8 from 2, there's a trick here. We need to just add 24 to 2 and then subtract 8. So 24 plus 2 equals 26 minus 8 equals 18. So we're looking at 18 hours, 55 minutes, 00 seconds. Or 14 minus 8 is simply 14 minus 8 should be 6. Or we're looking at 6 hours, 55 minutes, 00 seconds. So which local mean time, approximate local mean time, because we didn't account for minutes, which one are we in? Well, this is the afternoon, right? This would be PM, your 18 hours. This would be AM. Was the sun rising or setting when we did this? So the sun's bearing was 101. If it's over by 100, that means it was in the east. Sun rises in the east and sets in the west. That means it was rising. That means it was the AM. This is the AM. Our local mean time was the AM when we took this. So we go back. This is our GMT, 1455, right? After we corrected it. So our GMT in this case, Greenwich Mean Time, is equal to 14 hours, 55 minutes, 0 seconds. What day was this in? Well, we were 8 hours earlier when we took it. We end up in the same day. So there's no switch of the day. So we're January 11th. Figuring out what day it is one of the most difficult parts of this problem, in my opinion. So with this GMT, now we can get our declination. So we're going to get our declination, we're going to get our D value, figure out if it's added or subtracted. So we need to go in the Nautical Almanac for January 11th, 14 hours. We're going to be all the way at the beginning because we're January. So April, March, Feb, January 20s, January 11 in the sun column. So here we are. This is January 11th. So here's the days. We're 11th, January 11th, and we are 14 hours. 14 hours. So we get south 21. See these, it's implied that it drops down. So south 21, 45.4, and is it getting bigger or smaller as we go down? Smaller. So we're south 21, 45.4 getting smaller. South 21, 45.4. South 21, 45.4 getting smaller. Now what's our D value? D value is down here. D value is 0.4. 0.4. Now we go to the increments. 55 0. These are the increments. So we go to the increments, we got to get a D correction. So increments for 55 minutes. It's going to be all the way near the back. 51, 55 minutes. The increments. 55 minutes. And we're going the D correction, right? So 0.4, the correction is 0.4. And we already figured out that we're subtracting it because the declinations were getting smaller as we look to the next hour. Okay, so let's look at this. So we're south 21 degrees, 45.4 minus, so we're 45 minutes. Now, we need to get these minutes into degrees, so we divide by 60, which means now our declination is going to be equal to south 21.45 divided by 60. 45 divided by 60 equals 0.75. And these are degrees. Good. All right. So we can use those in the next step. And now we're going to need our latitude. And our latitude is equal to latitude 2430 north, 24 degrees 30 minutes north. And we need to get these in all degrees. So we divide by 60. So we're going to get our latitude equal to 24.30 divided by 60. So we get 30 divided by 60 equals 0.5, 24.5 degrees. And this is to the north. Good. North. We can use this. So now we're going to throw all this into a formula that says this. It says the sine of the amplitude is equal to the sine of the declination divided by the cosine of the latitude. Let's put these numbers in. So the sine of declination is 21.7. Sine 21.75 divided by the cosine of the latitude, which is 24.5. 24.5. And this, let's throw these numbers in. Sine 21.75, sine 21.75 equals 0.37056. 0.37056. 37056. Good. Let's crunch these cosine numbers. Cosine 24.5 equals 0.90996. 0.90996. These are a lot of numbers, so just take your time here. It's easy to mess this up. So now we do the division. So 0.37056, 0.37056 divided by 0.90996, 0.90996, 0.40723, 0.40723. Now this is sine amplitude equals 0.40723. To get the sine on the other side and just get amplitude, we're going to have amplitude equals the sine inverse of 0.40723. And we put this in the calculator. So go second sine inverse 0.40723 equals 24.03, but so just 24 degrees. So this is the amplitude equals 24 degrees. We need to name this because this came out in quadrantal notation. So first we name it east or west based on if the bearing was in the east. So we name it east, and now we need to name it north or south based on declination. Here we're south. So we are amplitude equals east 24 degrees south. Let's get it in degrees from true. That's what we need to do. So if we build this little graph, north, south, east, west, we can figure out how many degrees from north. We're east, we're this way, and we're 24 south, we're down here. So east 24 south, this is us. So we need to consider these 90 degrees plus our 24. So we get the amplitude is equal to 90 degrees plus 24 degrees. Our amplitude from north is equal to 90 plus 24 equals 114. 114 degrees true. Now we can put this into our compass correction, which we go TVMDC. True variation magnetic deviation compass. When we're correcting down, we add west. So we'll subtract east, and we do the opposite if we go up. So true. 114.0 degrees true. Variation was given 11.6 east, 11.6 degrees east, right? Yeah, east. Good. That'll give us magnetic. We're going down, we subtract east. So we got 114 minus 11.6 equals 102.4. So magnetic is that's not right. It's 102.4. And now our compass was given. The sun's bearing 101. 101.0 degrees PSC. So we're going from 102 to 101. We know this is going to be east because it's less. So let's do that. 102.4 minus 101 equals 1.4. 1.4 degrees east. Let's check it out. Here we are, the correct answer. 1.4 degrees east. So we just solved practice problem 6. You know what we did? We calculated the deviation based on the amplitude of the sun here.